Explain pam 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 pam, and after that you remove it. No, this is simple. But in some cases, you don't have this, and you don't have the box crimper, the big one. But you have this box crimper, and you need cutted cables, and you don't have this one. Don't try it with the regular wire cutter, the small one, because you destroy the cable, and you don't have a flat surface when you finish. No, I recommend a chisel like this, and the cable, and you cut it. And at the end is properly cutted. No, the chisel, over a piece of wood or metal, aluminum, soft metal, like this. All right, and after that, with your fingers, once again, with your fingers, you cut it, the excess of plastic, you see, guys? And now, it's easy, and you are ready. And can I have the box with terminals? That one? That one, thank you. And now, we are ready. Yep. And we are ready to, come on, or here.
Okay.
You hold it, both of them. And now you twist it 180 degrees.
Okay.
And bingo finito, properly crimped. But this is good on the ground.
Yeah.
On the table, no. Inside of the boat, no.
Yeah, you freaking throw your art off the boat if you use that on the teeth.
Claro. No, this is a great, in some cases, that crimper is better than the, yeah.
It is better, actually.
It's better. No, it's strong. And this is not expensive. This is not expensive.
And that's a good one to have. But the one you're gonna want to use in the boat's the hand one. That one you will use at the shop.
And you know how easy it is to cut it with the chisel? And you cut it perfect? No?
It looks easy.
But if you have the right tool, you don't need the chisel.
Yeah.
Yes. No, of course, be careful. Exactly with the knife, be careful when you cut the plastic. Practice, practice. Questions? No? Okay, let's go. Thank you, Danny. Now with the small terminal, oh, the other, yeah, the box. Now with the other terminal, you see? Okay, guys. If you see in that box, we have a lot of in the box we have a lot of yellow terminals, red terminals, and blue terminals, like this. This is because there are different gauge of wires, and each color is appropriated for some range of gauge. We are going to check what is the meaning of that. Okay, the box crimper is clear, no? How to use the box crimper. Be careful, no? The industrial and residential wires are solid. The industrial and residential wires are not allowed in the marine industry because they are rigid. They are rigid, and your boat is elastic. Your boat is in constant movement, and those cables, sooner or later, for fatigue, are broken. You know what is fatigue, no? Finito. All right. now we are going to check the connectors. Look at this. Those connectors are good for gauge between 18 and 22. The blue one between 14 and 16. The yellow one between 10 and 12. Yeah, all of those. Those terminals with those colors are with that material, soft material, is approved for marine environment, because this one with the heat are deformated like heat string. The other one with the open end, they are not marine grade. And this material is not thermoelastic. When you apply the temperature, it's not deformated, it's burned. For example, this one. This one is a rigid plastic. If and the end is open, you see? The end is open here, and the plastic is rigid. That's not good. When I crimp it, it's broken. If I apply heat, it's burned, but no cover the area. This is not marine grade. You understand? Always use terminals marine grade with the heat string incorporated. All right. ABYC question. In a terminal, how much is the maximum amount of cables allowed over there in that terminal? 4. No more than 4. This is one of the ABYC questions in the exam. Okay, guys? No more than 4. The crimper and the wire, we talked a lot about that. And now we are going to calculate the area in circular mills. Let me explain what is the meaning of that. We are going to use a formula to calculate the gauge of the wire, the area of the wire. And also, we are going to use a table that you have in the book to calculate the gauge of the wire. But before we start with that, I have a question. What do you think the gauge, the diameter of the wire depend of what? Excuse me?
Depends on the amount of power transfer.
The amount of current that is flowing for that cable. That's number one. And the other one? Excuse me? Okay. How much is the voltage drop in that equipment? Perfect. And the distance. The distance. Pay attention. 3 factors. How much is the distance between the source of the power, the battery, and the equipment? But in DC, remember that I did one circuit, start in the positive of the battery, enter in the light bulb, and return to the negative. You remember? In DC, I need positive and negative for the return. Okay. If the distance between the battery and the equipment is 25 feet, how much is the total distance? It's 50. Okay? Okay. We are going to use the distance, the total distance. We are going to use the amps, and we are going to use the voltage drop. That's clear, guys? All right. The distance is double because I have positive cable and negative, the return. The other one is the voltage drop, and the other one is the amps. Where I found that information about the amps of that equipment? On the label and the manual. You see? Oh, the fan. It's 7 amps. Okay. This is the amount of current that this equipment suction during the operation. That's clear, guys? All right. I have the amps, I have the distance, and the voltage drop. What is the meaning of voltage drop? What do you think is voltage drop?
The amount of power lost when
Well, you gotta put
Voltage drop.
the amount of
How much the voltage goes down
Yeah.
during the operation, during the cranking, during the start of that equipment. No? Let me check during the cranking of that motor. Oh, the voltage goes from 12.5 to 10.2. Okay. That difference, 2.7, is the voltage drop. How much drops the current? It's demonstrated, guys, that any type of lights, the voltage drop is 10% in lights. The voltage drop is 10% of the voltage of that battery. Okay, this system is 24 volts. Is the 10% of 24 in light. Oh, this system is 12. It's the 10% of 12 in light. Okay, in regular equipment, motors, fans, any motor, any load, any typical load, the voltage drop is 3%. 3%, 1 to 3, 3%. 10% for lights and 3% for the rest of the equipment. That's okay? And now I have a question. How much is the 3% of 12 volts? It's 12 times
3%.
0.03. 0.03. How much is the 10% of 24?
2.4.
No, 24 times 0.1.
0.
For lights.
10%. That's okay?
That's for lights.
That's for lights, for lighting.
So
Good?
0.01.
No, 0.01 is 1%. 0.1 is 10%.
Oh.
3% is 0.03. 0.3 is 30%.
Gotcha.
No. All right, good, no? We are ready. Look, 3% for panel board, feet, bilge, blowers, electronic equipment, navigation light, etc. And 10% for general lighting. And you can calculate the gauge in two different ways. With that formula that you have in the book, or with tables. We are going to practice with both of them. Look at this. The area, the unit used to calculate the gauge of the wires is circular mils. Circular mils. Okay, the gauge of the wire, American W, the AWG, the unit is circular mils and is equal to 10.75, this is constant, times the length of the cable, times the intensity, and divided by the voltage drop. What is the meaning of 10.75? Is a constant to convert units. Memorize that number. You remember the other formula with a constant that you learned in introduction? The formula to calculate the torque. You remember how much is torque? 52 times the horsepower divided by the engine RPMs. What is 52? It's a unit to convert units. That's okay? All right. For example, look at this. If the voltage drop is 3%, the following formula is recommended by ABYC to calculate the size of the wire. For example, I have a bilge pump. The bilge pump drops. The intensity of the bilge pumps is 10 amps. 10 amps. And the positive cable is running 10 feet from the panel, including the flow switch. The negative is running other 10 feet. Okay, how much is the total length?
20.
20. And what is the size of the wire? Okay, the size of the wire is 10.75 times the intensity and the length, times 20 and times 10, and divided by the voltage drop. Oh, the system is, what is the voltage of that system?
3%.
Oh,
It's 12 volts.
12.
It's 12 volts. Okay, the 3% of 12 volts is 12 times 0.03.
3.
3.6.
0.
Ah!
My bad, I put it incorrect.
Ah. How much is that in total?
0.3. Oh.
This one is
Bottom
0.36, no?
0.36, yeah.
How much is in total? Is 10, is 200 times 10 is 300 divided by 0.36?
5972.
Excuse me?
5972.
5972. Circular mills. Pay attention. 5972. This is the first method. Okay, if you go over there, the area in circular mills, 5972 is pretty close to 58. Oh, the gauge should be 12. This is using that formula. It's not complicated. It's nice if you have this table. But now I am going to explain other formula that you have in the book is the tables created for ABYC to calculate the gauge of the wire depending of the intensity, the distance, and the voltage drop. And can you open your book? Can you check this table in your book, guys? Guys, look, follow me. This table, please. Correct, that table. And look at this. Who doesn't have the book?
What page is that on?
42.
Okay. Who needs table? Who needs table? Okay, we are going to do another example. I have an equipment that look, I have a motor. The motor draws in amps 15 amps. The distance between the battery and the motor is 15 feet. How much should be the gauge of the wire for that cable? It's a motor, and the system is 12 volts. Using the table, it's 12 volts. Look at this. The first ones are for 12 volts with 3% of voltage drop. For 3% of voltage drop, 12 volts on top and 24 in the bottom. For 10%, with 10% of voltage drop, for 12 volts and 24. Okay, this system is 12 volts. How much should be the gauge of the wire, and which table you use?
What do you need to know, amperage?
Excuse me. The amps are 15 amps.
Oh,
The distance between the battery and the motor is 15 feet.
so
Um,
12
Excuse me, which table you use? The top one, the bottom one?
Top.
The top one? Okay, you say how much is the total distance? Look at this. The distance is on top.
Yeah.
That's 8 gauge? 8 gauge,
Is 30, and you go to 15 is number 8. Number 8. It's clear, guys?
Yeah.
So, when I looked it up, I doubled the 15 feet for the distance there and back.
30.
It's 30.
Yeah.
It's
Okay.
30.
So 30 feet, 15 amps, that says 8 gauge.
8 gauge.
Okay,
Correct.
all right.
You like it?
I like it.
Suppose that you have a light. Look at this. You have a searchlight. Searchlight. The intensity of that light is 30 amps. And the distance is 20 feet for the positive terminal. How much is the gauge of that light? And what? And the light is at 24 volts. The searchlight is 24. What table you use?
10 44 volt.
How much is the voltage drop? 10%. And 10% and 24 volts, no? In the second page, the bottom table, you see? 24 volts, 10%. How much is the total distance? 40. How much are the amps? 30. The cable should be
12.
number 12. Good?
Wait. Hold on. I don't understand. Wait.
Look, 40, the total distance, because it's 20. And 15, how many amps? 25 amps?
Wrong page.
Yeah, because
Wrong page. Yeah, it's the next one over. There you go. Oh, because we're using 10%. Okay. Okay. All right.
Dale, tranquilo, dale, dale.
So the table changes for the volt drop.
With the voltage drop.
Okay.
And depend of the voltage of the battery and depend of the voltage drop. But don't worry, you practice. We are going to practice more and more and more.
I get it. Though. I get it though.
Dale, dale.
That's easy.
I didn't understand the double part. That's a double.
Excuse me?
I didn't understand you have to double it.
Oh, because the current. Yeah, let me explain why.
You see. Oh, shit.
But this is not difficult. It's practice.
You gotta know new shit.
Because now it changes. Because now if you have one ground it's taking all the power going down to.
You count that.
You would count that one. That cable would be different.
But you count the distance of that cable.
Muchachos, chicos. Later, those tables are exclusive. Those tables are exclusive for AC. The next tables are for AC power, and we are going to use later those tables, the other ones. For now, only DC. Only DC. The next tables in the next coming page are for AC.
We're gonna be using this to build, like to make wires.
Correct.
We'll be using this both.
Correct. My friend, because, papis, follow me. Because I don't have the book all the time with me in my hand. I take a picture of this, of each table, and I have that picture in my phone. Because I don't know where I am working and I need calculate gauge. And I have the picture of the table. I expanded the table, it's 20 and 40, it's number 10. That's okay? Always the distance is here, and here are the arms. And you go distance with arms, and this is the gauge. That's not complicated. But the most important is, what is the voltage of the system? It's 12 or it's 24, and the voltage drop. It's light, 10%. It's motors, 3%.
What measurement is that?
It's circular meters. It's 6 circular meters. 1,000 of millimeters.
Oh,
Mils.
mils. So
1,000 of millimeters.
Oh wow.
Check in the book, I explain what is the meaning of mil. Excuse me?
What's the point of circular mills? Why are we using it?
Because you know that each system try to be your own measurements, your own units, and try to be different than the rest of the of the system. No? The electrical system is not the exception. They have your own measurement, and they create that unit, circular mills. No? It's 1,000 of millimeters. The diameter of the wire in 1,000 of millimeters is that 8,000. Yeah.
So it measures.
To measure the circle. Yeah.
Some cable is sold as millimeters as well, right? Like you don't always often find 12 gauge wire. It's in millimeters. Sometimes.
Here in the U.S., when you
In
look
the
at
US.
maybe
Yeah, I've seen it recently.
But this unit is universal. Doesn't matter if it's Europe or America, circular mills is universal. It's universal. And number 10, number 8, number 12 is universal. Let me explain something, guys. In general, if I have, let me show you. If I have wires, yeah, guys. Look at this, guys. Look at this. This wire. Number 18 circular mills is small. 16 bigger. 14 yeah. When the number decrease, the diameter increase, increase, increase.
Why?
No, because this is the nomenclature to identify that.
I thought it meant like 18 and then 1,000.
Pay attention. The people say, oh, 18 is bigger. No, no, no. 18 is the smallest wire. Oh, number 0 is a big cable. We have no 1 0, 2 zeros, 3 zeros, 4 zeros. Bigger, bigger, and bigger. This is how many zeros? This is 2 zeros, I think so. Okay. Yeah, this is 2 zeros, and this is number. This is number. One. No, 1 0. No. Number 2. Look at this. This one is number 2, and this one is 2 zeros. You see? Goes up, up, up. When the number decrease, the diameter increase. Memorize that. Oh, 18, 20, 22. Smaller wires, smaller wires. Yeah? Okay. In marine applications, we are working between 14, 12, 10, and 8. Between 8 and 14 in general. What is the smallest wire recommended in marine application for marine wire wiring? 16. In the ABYC exam, they have one exception, and they say for speakers, video, and audio is authorized 18. Smaller wires, but at the minimum in regular wires, the panels is 16.
So panel cabling, your panel boards tend to be 18, right?
No, 18 no. 18 only in video and audio. The smallest in regular panel 16. 16. Look at this. This is 22. But this is an exception for that specific element. But in general, in the board, you have a minimum 16. The majority of them 14, 12, or 10. All right, guys? The only that I want that you memorize is the minimum gauge recommended by ABYC is 16. All right? The battery cables are normally between number 8 until 1 zeros, 2 zeros maximum. Battery cables. Look, this battery cable is number.
Number 2, and the one you hit is 1.
This is 1 0, 1 0, and number 2. Battery cables. 1 0 and number 2. Battery cables. Battery cables. That's okay? Battery cables. Normally the battery cables are located here in that area. The other ones are feeders for panels, and those number 18 and lower for electronic devices. 18 and lower electronic devices, electronic equipment. Good, papas? Okay, pay attention to this. In the future, look at this. You need order. You need order. Wires. For example, this one is Pacer. Pacer, my friends. Number 4. Battery cables. Number 4. No? Battery cables. And this is a roll of 50 feet. We bought in Pacer this roll of cable. Pacer Marine. And also, this one is gauge 14. It's 100 feet. It's a smaller wire, you see? 14. The minimum accepted is 16 for panels. This is 14. And this
For
is 4.
rewiring, I would probably only use 14.
Yeah, a lot of 14.
16 is too small.
And of course, you need crimped small wires, medium wires, thicker wires with crimpers. The small ones you crimp it with this, no? Now you will practice with Danny crimping those type of wires with those tools. You need bring every day your wire stripper, your crimper, and the cutter for the battery cables. Okay, both of them. Oh, every day, and the multimeter. The multimeter is mandatory. Okay, guys. Good? Clear?
Clear.
Don't forget, only use marine grade cables. And the marine grade cable, they say in the label marine grade. Pacer marine grade. All of them. If it's not marine grade, don't use that. Because those marine grades, the filaments are covered with silver. They avoid stop the corrosion. Okay, guys, look at this. What happened when I don't use marine grade cables? That's the consequence. That's the consequence. Corrosion. And this is a marine grade cable. It's a huge difference, no? Never use non-grade marine cables. Okay, colors for DC power. What is the color? Okay, this is a duplex cable. You see? Duplex cable, because it's coming in. And this one, this one is triple. There are other ones with 4. Yeah? But all of them are marine grade. Okay, let me I explain something about this. Okay, what are the colors recommended for DC current? For positive, red. For negative,
Black or yellow.
black.
Or yellow if there's
In the
AC.
future, they replace for yellow. Starting in 1995, 96, the regulation ABYC recommend replace the black one in DC for yellow one to avoid confusion with the black one in AC.
Gotcha. So
No?
if you have a boat of just DC, you would just do black, red, but if there's AC, you add the yellow as your
Yeah.
AC negative.
But no problem if you use black, no problem. But it's better if you use yellow one. Yeah, the black one was replaced for the yellow one to avoid confusion with the hot. Okay, my friend. Later we are going to work installing everything: the oil pressure gauge, the temperature gauge, the fuel gauge, tachometer, ignition, and we are going to memorize those color codes. And in the future, if I ask you what is the color for ignition cable, and you need to respond immediately, purple. What is the color purple here for ignition system? What is the color for the signal on the oil pressure gauge? Oil pressure, light blue. What is the color of the cable for the signal on the fuel sensor? And you need to respond immediately, pink. Okay? We are going to memorize that table, not today, but in the moment of the project. The quiz is oral quiz, no? Oil pressure, tachometer. You need to memorize those numbers. Those numbers are universal. Let me explain something about that. Those colors are universal. And what is the idea? That if you are in the console working, you have a million of wires, no, in different colors, but you have one cable hanging, pink color. Oh, this is fuel. This is fuel. Excuse me, your fuel gauge is working? No, it's not working a week ago. Oh yeah, I found that the cable here loose, no? Something like this. Or, I don't know, Mr. Lopez, but my tachometer is not working. Everything was good until the last weekend, and today no tachometer. And you check what color cable you need check in that moment, in that million of wires. One color, gray color. Oh, it's burned here, that cable, because it's close to the cigarette lighter and pam and some pam. This is why I don't have tachometer. Those colors are universal. And in the future, don't try to use, oh, I have excess of orange. Let me use for, no, my friend. Orange is exclusive for, what is the color for orange?
Accessory.
Accessory, no? Something like that. Orange, yeah. No? Each equipment have your own color.
Would you say it's fairly common to see the wrong colors used for the wrong systems?
Correct. For example, people that is not a marine grade technician, excuse me, electrical technician. Hey, my friend, why you wire with red everything? I don't know which one is ignition, which one is fuel, which one. Oh, but it's running. Yeah, I know it's running, but how I identify that? I have 1 million of red colors. No?
For the a.c.r, if they're maybe not in a panel board, but if they can be the same color if they're properly labeled.
Okay.
Like what's the...
All right. Some manufacturers, they use the same color for all the cables, and they put labels. No? Labels with letters and numbers at the end of each wire. For example, the fabricators of generators, some of them use white color. The harness is completely white. But you need to follow the cable, and with the magnifier, oh, this is A134. Oh, A1 is the light.
Well, they fade too. Then
Yeah,
There could be
I prefer
confusion.
the color. For example, let me explain.
Frankie, is the battery cutter over there? Is there a battery cutter? You stole your battery cutter? Yeah. There it is.
This is the harness. This is the harness that I use to. I have the generator here, but I want the remote panel on the cabin. And this is the harness to connect the generator with the remote panel. And you see the colors? And they follow the colors, the color codes, and it's easy. Oh, I have a problem with the ignition. Okay, they have the red with purple. This is ignition. They have white. They follow the color codes, and this is why the people love it, this type of generators. But the other generator, all the 100 cable white colors. Identify that one is, no, Danny, you pass the day.
If someone comes to me with a boat that's all red and black, I give them a price on a new rewire.
Yes.
Because your guess, how do you know which wire? And if it's not even labeled, it's even worse. Color coded. Sometimes you have replication of colors, then you definitely, no matter what, you can put labels. They sell labels with heat shrink with labels on it.
So in that case, I have to rewire the whole book?
Well,
You don't have
obviously
to.
depends. If he's gonna have a whole sort of electrical issues, think of how much time you're gonna spend trying to troubleshoot each wire. You look at the spool of wires in your boat. It's all red and all black. Where do you start?
how would you check them?
Yeah.
You would have to go to the component. You would have to have one guy in one component give power. You go with the other guy would check to see where the power, take the power off. Okay, that's the wire. You only know from one end to the other, but if it's in a big spool of wires, how are you gonna know which one it is? Unless you what? Probe the wires, which you're not supposed to.
Would you do continuity? You'd be like,
You can do
and then
continuity,
your whole
but
meter?
you know the continuity from end to end. But how do you know which wire is the one in the middle?
Or you got the guys kind of.
Well, you have to probe it. You don't want to probe the wires.
You can use the same
Color
color,
code.
and
Color code, yeah.
you can mark with labels. You see the labels in letters and numbers.
So then you get the clear heat shrink. And
But
you
it's
clear
a lot
heat
of
shrink,
work.
'cause if you just put the sticker on there, it's gonna come off.
It's a lot of work.
It is a lot of work. That's why you charge a lot of money for wiring.
Okay, don't forget that we need. I love the practical solution. No? The practical solutions are quick, but in some cases you need more detail because the practical solution probably is not exactly the number that you needed. No, for example, to calculate the gauge of the wire, you need the distance, you need the amps, and the voltage drop. Okay, but in some cases, you don't have that information, and you need approximated what gauge of wire. You can memorize this table. Look at this. For cable number 2, you can move it around 95 amps, 100 amps. For cable number 4, you can move it 70 amps. For cable 16, it's good for 10 amps. For cable 18, it's good for 7 amps. That table is nice. If you memorize those numbers, it's good.
Can you use like number 10 with 30 amps, but you know, make it supply like only like 7 amps? You put like a set, like if you're
If the consumption is less, no problem.
okay.
Yeah, no problem.
Well, just think
But
of-
not too much.
Yeah. Just think of the wire feeding to a panel. You have to calculate all, if you turned everything on at one time, what would be the total amperage you would use, be consuming at one time to know what